Today we're talking about a very fancy sounding idea, communication protocol. So that's just a term we use for how one electronic device talks to or sends information back and forth to another electronic device. And with musical instruments, the communication protocol is called MIDI. That stands for Musical Digital Interface. Let's get to the next slide so we can move along here. All right, and it's the language of ones and zeros that these two devices are going to use to talk to each other. One might be software, one might be a physical box, it doesn't matter. As long as there's a wire connecting them, we're talking about the type of information moving along that wire. Now, you already know about some protocols. So how many times have you seen HTTP on the front of something, right? And that's another protocol. The P is for protocol. So that's a hypertext protocol that's used to send information between web pages. So this isn't unfamiliar to you. It's just a new type of protocol that musical instruments like. Why bother? Lots of reasons. And the more devices and software you have, the more reasons. So say you have a great device, let's take a look at one, that is really good at sequencing notes. So this is my favorite guy, the OPZ. Whoops, kind of hit the wrong button on that. Okay. Yowzer. My pen went away and instead it's clicking me on slides. Let's try and fix that up. So the OPZ is really great at being a sequencer. Okay, that's something it does really well. It actually doesn't even need a computer. It's got so much processing inside. It's an amazing one. And we have 12 of these sitting around in a cabinet at school. So if you'd like to use one for a final project, let us know. So you just click on these buttons as you go along and you say, okay, here's the beat I want, or here's when I want those samples to play. So it's a really nice interface for building beats. But maybe you'd like that to send that information into a program you have on your iPad that's really great at making sounds. For example, this one is called AudioKit, all right? And SynthKit is a synthesizer in the style of the old DX7, if you ever saw or listened to Phil Collins songs from the 80s. All you heard during the 80s was DX7 from Yamaha. It was an FM synthesis kind of first FM synthesizer, and people went nuts for it. So now you can get it as a free app on your iPad. We live in amazing times. But maybe you don't like having to push those fake keys on the flat surface of the iPad. And what you want to do is set it up with the OPZ. Well, the OPZ can be connected to the iPad and give MIDI information back and forth. Let's think of another example. Let me do my slide clicking here. I've got a Korg Kronos at home. Okay, so my Korg Kronos does all kinds of things. Oops, turns out that works differently than I thought. So the Korg Kronos does all kinds of things, but it has this really gorgeous 88 key, really FITAR keybed, this really piano-like set of keys. Well, I might like to play that and send the information to Ableton so Ableton can store it as the notes I played, and I can come back later and say, oops, I made a mistake, and grab two of the notes and move them. Or say, oh geez, I really was playing too fast, let me slow it down. Or, oh geez, I love the way I played it and I loved the sound I used, but it really should also be done in a piano sound, and I recorded it in a guitar sound. Let me change the sound. All of that's possible once it's digital information inside Ableton. So I need a MIDI cable to connect them and talk back and forth. And in Ableton, I just say, take the MIDI that's coming from the Korg Kronos. Okay, so there are all kinds of uses for this, and it shouldn't be a mystery to you. We want to have you skilled to the level of understanding this kind of digital communications, these kinds of tools, because you'll see them in all kinds, whether you end up in music as a career or not, you'll see this in your discipline for sure. So getting back to MIDI, how do you connect these two devices together? Well, you basically have three choices at this point. The oldest choice is called, I can't do this for the life of me. There we go. is called a DIN, a 5-pin DIN. And if you look at it, you can see the 5 little, what should we say? You know, they're here they are in the male side. These are when you have a cable and the little prongs stick out. They're called male. This is called the female side when you have a cable and you have the little holes for them to come in. So this is a USB, I'm sorry, this is a MIDI DIN 5. And you see those on older, larger pieces of equipment, okay, where they didn't mind having that much space dedicated to MIDI. But if you look at something like our Novation, it's so thin. Who's even going to put a 5-pin MIDI connector in? So now there's something used called a TRS, transmit and receive in stereo. So you've got 1, 2, 3 parts. You see 2 little rubber gaskets. That's how you know it's a TRS. 3 sections, and it's so small. In metric, it's actually 3.5 millimeters. So ignore this part. If you have to go from your Novation to an old piece of equipment, you could use something like that, but usually you're just going to have a TRS cable on one, TRS cable on the other side, and you're going to plug it into modern devices, and they'll speak MIDI to each other. With my Kronos, I just have a USB connection. And I just take a USB from the back of the Kronos and I plug it into my computer that's running Ableton. Boom, they're talking. They're talking MIDI. And by the way, when you're talking MIDI, you're talking 16 channels on one wire. So whichever of these you use, you're going to have 16 different instruments that can be sending information across. So you might have a piano sound, you might have a guitar sound, you might have a drum kit. They can all be sending information across the same wire. So this is fantastic, huh? You want to know more? I'm sure. Don't forget, one of the features, oh, come on, one of the features on your Novation is that you have a MIDI out. Now, which one is that? Is that USB? Nope. Is it DIN 5? Nope. TRS, that's right. You've got a TRS MIDI connection. It doesn't send MIDI both ways. This just sends MIDI from your keyboard out to another device. But that's great because you might have all kinds of things that make noises and do synthesis, but they don't have a keyboard. So now your keyboard can be attached. And that's really unusual in this price range. So we shopped really hard to find you guys a great tool. So if you're not really interested in technology, just zip through this part. Okay, a little fast. This is a little extra. I want to make sure it's in here for people who really always want to go a layer deeper. So what does the MIDI on that wire look like? Well, let's go all the way down to the bits. Okay, a bit is just a 1 or a 0. And if you put them in a group of 8, we call it, this is getting old, we call it a byte. There we go. I'm not hitting it hard enough. Okay, so that's an example of a byte. You get it? This is computer humor. A little bit and a byte. I'll even give you a clue. Those little 4, the first 4 of bits and 1s and 0s are called a nibble. Right? That's just adorable, huh? So that's the language we're going to be talking about. And bits and bytes, that's what's on that wire. Okay, it's a stream of 1s and 0s. And then they're understood as representing numbers, whole numbers, numbers like 1, 5, 6, 10. Okay, so how do we make 1s and 0s do that? Well, there are different systems of numbers for doing that. You're used to them. You're used to base 10, right? You're used to seeing when I write down 43, you go, oh, it's 4 bundles of 10s and then 3 more. If I said 643, you'd say, oh yeah, add 6 bundles of hundreds. We have digits, 0 all the way up to 9, and we use them to represent a count of things, and that's the same thing that happens in binary or hex. In hex, instead of 10 numbers, we have 15 digits. So how do you do that, right? What do you write down after 9? It has to be a single digit. It has to fit in one box. So you go 8, 9, and then what are you going to do? Squiggle symbol or like little, Kryptonian looking symbol. Well, they're not on keyboards. So they just went with A, B, C, D, E, F. So these just are single symbols that stand for 10 all the way through to 15. Okay. Here we go. You don't need to know the details of how to add these things or convert them because any calculator on any computer you're sitting at can do it. I happen to be sitting on a Windows computer right now, so here's the Windows calculator. If you put it into programmer mode, all right, which you do by hitting that little hamburger guy there and selecting programmer, now it says, I know you. You're a person who really loves programming, and I know what's important to programmers. Bits. So let me offer you any representation you want. Do you want to see what it looks like in base 2 binary? Check. Do you want to see what you regularly think of, like decimal? No problem. You want to see it in base 16 hex? No problem. And you notice when we're in hex mode, it actually says, I know that when you live in hex world, you need more than just these 10 digits. And there they are. So I can say, okay, I've got the number 7F. That sounds really weird to us. If you're new to computers, you may have seen wacky messages that talk about things that have E's and F's in them, but you probably had no way of knowing what they meant. All it means is 127. It's another way of writing the number we're used to seeing as 127. And that shows up a lot in music and digital music theory. So we'll keep in mind that it's interesting that it happens to be the number you get if you have a 0 and then all ones in your byte. Okay, so that's just some information we'll get to down the line. Come on, give me a break. All right, so the MIDI message then is these ones and zeros, and they're being understood as hex or binary. They're being understood in a certain way by the program at the other end. And we're going to start off, there are a lot of MIDI messages. We're going to start off looking at standard MIDI messages for notes, and they are 3 bytes in a row. Watch me go the wrong way again. Oh, there we go, good. So the first byte tells you 2 things. What kind of message is this? And by the way, of these 16 channels, which one are you talking on? So you need 2 pieces of information in that, and you can guess, right? We said a byte is 8 bits, right? It's 1, 2, 3, 4 bits here, and then another 4 bits here. One of them is used to tell what type of message it is, and the other one is used to tell what number the channel is. Now the second byte has to tell you the details. If your first byte said, okay, I'm giving you a note, second byte has to say which note. And then the third byte finishes up the rest of the details. How loud is that note? So here it is. This is MIDI. So MIDI, if MIDI was going to talk from my Korg Kronos piano, okay, and it was going to go through a USB cable over to my computer that has lovely Ableton Live running on it, it's going to send a pattern of ones and zeros, which in hex would be called 8C. Oops, I wrote that wrong. 8C, 50, 7F. And what that means, here's the message, 8C, 50, 7F. Here's what it looks like literally on the wire, right? The wire has all those ones and zeros on it. And here's what it means to Ableton. Ableton says, okay, let me look at the first byte. Oh, you've got an 8? 8 means the message, I am a musical note, turn me on. Okay, that's easy. If you had wanted to turn it off, it would be a 9. If you wanted to send a pitch bend, it would be an E. If you wanted to tell how hard it was you were pressing on the pad, the drum pad, it would be a D. Okay, so there are different messages. The one we're sending with this one is, I'm a note, turn me on. Well, if you're going to tell me that you're going to turn on a note, the next thing I need to know is which note? Is it low C, high C, a D, an F sharp? Which note is it? And how hard did you push the key? Meaning how fast did you hit it? Meaning how loud is it? So this is a confusing thing to an engineer. This is just the musicians. I mean, they're not really talking about the velocity. They're talking about the volume. They're talking about how hard you want the note played, how loudly you want the note played, but they think of it as how fast you hit the piano key. Remember, MIDI was created a long time ago, so there are pretty much just people sitting around playing pianos back then. If it had been a pitch bend note, you might want to just tell me one thing, like which way, how much pitch bend, up or down, how much pitch bend. If it was a pressure, you might just need to tell me the value. Okay, so 8 in our secret message means turn a note on. C means do it on channel 11. This is in hex, remember, so if you look it up, it means 80 in decimal, and that tells you which note. And 7F is loud, 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 as loud as you can make it. So there's an example all the way down the stack from the idea that MIDI is a cable connecting two things, that it sends ones and zeros across to communicate. It sends, those are understood as messages, like turn my note on, turn on F sharp and make it loud. And if you were to go all the way down inside the wire, you would see messages that look like this. So let me just tell you a secret. There's no place else to go. This is a lot for a first pass, but this is everything. Okay? There's no engineer. Steve Duda doesn't know any more about MIDI than you right now. That's it. This is all there is to it. Okay? So come back and we'll be using this over and over, and you'll see there are other things to do with MIDI, other powerful uses, but I wanted to give you all the detail you would ever need right up front, because I believe throwing you in the pool and having you sink or swim will pull you to the surface later. Now, the good news is you don't need to know any of that to do MIDI in Max. Okay, Max has a bunch of objects in it related to MIDI. So let's start at the easiest level. At the easiest level, they don't even talk about MIDI. This is just super easy. They just say, you know what, I get it. You want to make a note. You don't want to worry about MIDI. Here's an object called make note. Give me 3 things. Tell me which note. Tell me how loud to make it. Remember, they call that velocity. And how long do you want me to hold the note? You send those 3 messages in. Okay, so make note has 3 little inlets. You're going to find a way to send messages in there. They might just be a message, or it might be from a slider or a dial. I mean, there are all kinds of ways we can do that. And then note out makes sound. So make note and note out are good ways to get started. But pretty soon you're going to want to start interfacing with the real world and getting more detailed into the pieces of these messages. So then you're going to move to 2 more objects called MIDI in and MIDI out. So make this little patch. Go right now, open up Max, and clean everything out, start a new patch, and just put in MIDI in, MIDI out, lock it. Okay, remember you have to do the little lock every time to run it. And double click on MIDI in. And it will show you all of the MIDI devices that you have connected to your computer right now. If you haven't got your Novation plugged in, it won't show you much, but plug in your Novation and you'll see the Novation come up. Here I have a Launch Key Mini MK3, and it's looking at it in 2 different styles. But if we pick Launch Key Mini MK3, then everything we hit on our Launch Key MIDI comes through that MIDI, and we can process it any way we want. Remember, every program we have input, process, and output. So this takes care of the input and output that you need for MIDI messages that you can enter into your Max program from your Novation Launch Key. So I'm sure your mind's blown right now. Like my mind's blown just hearing it, right? Like that's crazy far to come in just this much of the semester. So let it soak in. Let it soak in. And I'll add two more before we get out of here. I'll add two more little methods, two more objects that are really handy called join and unjoin. So sometimes, you have a number like 6, and sometimes you have a set of numbers like 6 and 127. You might call this a list, right? And you can tell we have this a lot with MIDI, right? So a lot of times we have the name of the note, like it's an F sharp, say, and say that's a 67. I don't really know what it is. And the volume, and that can be between 0 and 127. Right now it's 127, which is loud. So we wanted to send a message that had those two pieces of information, which note and how loud. So in our programming language, Max, it says, okay, you've got two pieces of information. This one makes sense as volume, would it? Negative 116. Join them together so that it's one thing, 99 and minus 116. That's what join 2 does. It gives you two inlets and joins them into a single thing. And of course, if you at some point want to unjoin them, you just run it through and unjoin, and out come two outputs. So these are all the pieces we need for the homework this week, okay? The very simple beginning make note, the more interesting MIDI in, MIDI out, and we may at times need to be working through join and unjoin. Everything else is handled by MIDI Parse and MIDI format. So we'll look at these in the help patches that are included. That's where these examples are from. And so remember, we started out talking about like 8C, 5-0, 7F. So if you know that stuff, you're superhuman, right? I wanted to give you everything, but that's superhuman. If you're a Max user, you don't even have to see that. If you're a Max user, you just take the MIDI from your Novation keyboard and you run it into this MIDI Parse box. And it says, I gotcha. I know what's going on here. You want to know if this is a note on message. If it is, you're going to want to break that into two pieces, and you're going to want to know that there's a note and a certain volume. You might want to have a pitch bend message coming instead. Then I'll ignore that and I'll come down here and I'll show you that it's a pitch bend. All of these messages come across a MIDI channel. Don't worry about it. The MIDI channel is, we know, coming from this part right here of the message, right? That's a number between 1 and 16, and it's 0 through F in hex world. But who cares, right? We don't care anymore. Now we have, stop it. We have MIDI Parse coming along and breaking the message up for us and changing it into things we can easily understand. MIDI format just goes in the other direction. You send it the pieces of information and it turns it into a MIDI message. Now, if you go into Ableton, you also see MIDI mentioned in this MIDI effect category. And so Ableton comes with a whole bunch of effects that can process the MIDI before you even play it, right? Before it even goes into a software instrument and becomes a sound. So we've seen MIDI does things like tell you which note or tell you the volume. And that's what these manipulate. So for example, the chord effect might be you play one note. And what we do is we look at the note and we say, oh, okay, we're going to add 3 more notes. We're going to add a note that is an octave above. We'll add 12 and make a note an octave above. We'll subtract 12 and make a note that's an octave below. And those 3 messages, those 3 MIDI messages will get sent out. You can add 7 notes to it. You can create incredibly complex chords, and you're just holding one finger down. That's because there's a Max patch that looks at the MIDI message coming in, processes it, and and sends out a more complicated set of notes. And so I encourage you to play with these. You see they change the note length, they change the pitch, they might randomly give you notes. This is a very useful one that says, you know what, maybe you're not interested in spending hours and hours of your life learning every single scale. Okay, you still should be allowed to make gorgeous music. You're a human being, that's your right. So if you just hit all the white keys on your Novation launch key, they make sense, right? That's the key is C. But you don't have to live there your whole life. You can move into some fancy key like F sharp minor. Who even knows? Who wants to take a whole music theory course to learn what the F sharp minor key is, right? So you just drag this little box down. You say, I want F sharp minor. And every key that comes in, it looks at it. It looks at the note value. It says, well, that's not in F sharp minor. Let me move it. And it moves it to the correct note in F sharp minor. So you can't play out of key. You can bang any key on that Novation. It'll come out in F sharp minor. So now you're starting to see the power of MIDI and why we bother to do this, okay? So what we're going to do on the homework is we're going to write a max patch that'll sit inside Ableton Live and just open the magic on MIDI. It'll show you what's going on as you play notes in a variety of ways. So we can use the MIDI information and create a tool that sits in the device rack for Ableton and shows you the name of the note. Now, if you're not a musician, there's more than one C on the keyboard, and so musicians name them. The first time C shows up on the keyboard, the second time C shows up on the keyboard, the third, okay, the different octaves from very low to very high. So we can display the name of the note. Maybe you don't know how to read music, right? I don't know how to read music. My husband's a professional pianist. He doesn't know how to read music. He just didn't come up. He didn't get taught that when he was in North Philly, and so he learned music his own way. But you can get started in that by using this scale tool in Max, and every time you play a note, it'll be displayed properly in musical notation. Okay, so we're going to take care of that. You might want to hit one of the drum pads on your Novation and see how hard you pushed it, and we'll display that. So that's going to be the homework project we work on. We're going to build a device that runs in Ableton using Max and shows you the useful information that you can get from a MIDI message that's being sent from your Novation into Ableton. So that's been a lot. And if you want to join us, Jen and I are doing a live Thursday night review of all of this information, and we'll have fun. Wally the mascot will be there. Maybe Mr. Noodles will make an appearance. We'll show you the Novation live as we play with it. So feel free to come by Thursday night on Zoom if you want to go over this again. But let's just do a wrap up for now. So MIDI is a communication protocol. That's an important phrase because that makes you sound very interesting and esoteric and very sophisticated, and that's how you get a bigger salary. So say, oh yeah, I know many communication protocols in your interview. You say, of course, HTTP we use all the time, but I spend a lot of time with MIDI because I'm a musician. So it's the specific communication protocol that lets hardware and software send information and talk to each other. And you have to have some kind of cable. It might be one of those 5-pin DIN cables. That's 5. It might be one of those little teeny TRS cables that has a little rubber gasket here and here so that you have 3 separate sections. Or it might be your favorite old USB cable. But on that piece of wire, whichever one it is, 16 different channels of MIDI information can be sent across at the same time. And they can go back and forth. Now, your Novation only has MIDI out, but many devices have MIDI in, MIDI out, and MIDI through. So the messages tell things like, turn on this note on a certain channel, turn it on, and you tell the note and you tell how loud you want it to be played. There's another message. That was message 8, remember? There's message 9. Turn off that note. Knock it off. That's how it's played long enough. On your Novation, you have a slider. Sometimes there are devices that have wheels. If you have a different kind of controller, you might have a wheel instead of a slider for pitch bend. Wow, 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 right? So you've got that 0 in the middle, and then you can pitch it up or pitch it down by a few notes. Pitch bend is a different code MIDI message. I forget which one. Is it C? I don't know. Inside Macs, you don't have to worry about the details of the 1s and the 0s. There's MIDI in, MIDI out, and there's MIDI format and MIDI parse. Okay, parse means to take apart, to break down the meaning of something. So the common English word, right? If you say, boy, I couldn't parse what he was saying, it means that you couldn't break down into the little pieces the words he was saying to get meaning out of it. Format means you're putting them together according to certain rules. And MIDI effects can be designed and written in Macs and live inside Ableton, and they can change all the things that MIDI knows about. Which note you're playing, how loud you're playing that note, how long you're playing that note. You can add more notes. You can change the note. You could even change the instrument by changing the channel. So we can talk about those things in more detail, and you can do something interesting with a final project around that. I think that's more than enough. Thank you for hanging in there with me. And what we're going to do is review this again on Thursday night live, if you want to come to that. The homework project doesn't require all of this information, so relax. Okay, this is a lot, I know. We'll be talking about this again next week, and we'll be talking about MIDI on and on for the rest of the semester. It's not that hard, and it's not that tricky that we have to keep talking about it, but it's that important that we want to keep talking about it until it's so automatic for you. You're like, oh yeah, I know, note on, yeah, I you know what, did you know, I mean, the code for that's 8. Did you even know that the status byte starts with an 8? I mean, you're going to know so much about this, you're going to be the cat's meow. So take a look at some of the other pieces we have posted in the course materials, and take a look at the homework set tonight, homework set for this week. Okay? Talk to you soon.